Hello everyone. Today we're going to be studying oxidation numbers. This is actually section 2 from chapter 7 for general chemistry for McDougal, and in my book it's actually page 220. So without further delay, we're going to start with learning the guidelines that we should abide when we are trying to assign oxidation numbers. So I'm going to move to the first rule. The first rule says that atoms in a pure element have an oxidation number of 0. For example, the atoms in pure sodium, Na, oxygen O2, phosphorus P4, and sulfur S8 all have oxidation numbers of 0. So whenever I have an element that is in its pure form, okay, that means that it's not an ion, okay? Make sure that you know that it's not an ion. It does not carry a charge. So when it's in pure form, the oxidation number is always 0. And it's worth knowing, and it's going to be really helpful for us for coming chapters to know that sulfur in its pure state has the form S8. All gases has the diatomic molecule form, O2, N2, Cl2, I2, F2, H2, okay? And for phosphorus, it's P4. The second rule says that the more electronegative element in a binary molecule compound is assigned the number equal to the negative charge it would have as an anion. So, and the less electronegative atom is assigned the number equal to the positive charge it would have as a cation. And that is actually best reflected when we have ionic compounds, when we always have the cation in the beginning. Okay, so the cation is always to the left, and then the anion is to the left. So the cation always carries the positive charge, and the anion always carries the negative charge. The third rule says that fluorine has an oxidation number of -1 in all of its compounds because it's the most electronegative element. Okay, so we studied before the trends in the periodic table. The trends in the periodic table show you that as you move from left to right in your periodic table, you move towards the elements that have higher electronegativity. And for those that need to refresh their memories about electronegativity, it is the ability of an atom to, let's say, it's the ability of these atoms to actually attract the electrons in the adjacent atom. And in other words, it's like saying that the anion always likes to gain electrons. And that's why in the ionic compound, I mean, if I want to talk about this, I'll never end. I'll never stop ending because, chemistry is one of those subjects that is always accumulative. And this is actually the cool part of studying chemistry. Whatever you learn is always going to be beneficial for you in the future, in future chapters. So you can just never stop getting enough of chemistry. So anyways, let's move now to the fourth point. The fourth rule says that oxygen has an oxidation number of -2 in almost all of its compounds. Exceptions include when it forms peroxides, such as H2O2, in which its oxidation number is -1. Okay, before I continue that, so oxygen, this is how we're going to memorize this. Oxygen, the oxidation number of oxygen is always -2 unless it's a peroxide. Now the peroxide has the form of X2O2. So if I want to give you the general form of a peroxide compound, okay, it's going to be H2O2. And in which the oxidation number is going to be -1 in this case. And when it forms compounds with fluorine, it's going to be +2. So it's always going to be +2 when it's with fluorine. So for oxygen so far we have 3 oxidation numbers, -2, Okay, this is I mean, you're always going to assume it's -2 unless, now this is conditional, unless it's a peroxide. So, okay, it has the form of X2O2. This is what we call a peroxide. Okay, X2O2. So in this case, H2O2, it's going to be -1. Another example is Na2O2, for instance. Okay, and then it's going to be +2 when it's with fluorine. Why? Because fluorine is the element that has the highest electronegativity in the whole periodic table. Okay, number 5 says that hydrogen has an oxidation number of +1 in all compounds containing elements that are more electronegative than it. It has an oxidation number of -1 in compounds with metals. So hydrogen has two oxidation numbers. It could be +1 or -1. And then number 6 says that the algebraic sum of the oxidation numbers of all atoms in a neutral compound is equal to 0. It's equal to 0. And we're going to see that when we start giving you some examples. So the sum of the charge, or the sum of oxidation numbers for any binary compound, has to be 0. Has to be 0. Number 7 says the algebraic sum of the oxidation numbers of all atoms in a polyatomic ion, now this is for polyatomic ions, is equal to the charge of the ion. Now, examples, I wrote some examples here. So when we say SO4, sulfate, the -2, the charge that appears on the top here, is actually for all of these atoms. And the +1 here for the ammonium polyatomic ion, the NH4 plus, the +1 is for the whole atoms, for all of these atoms. Same here, the negative for this chlorate ion is always -1 is the charge for the whole group of atoms. Number 8 says that although have been applied to covalently bonded atoms, oxidation numbers can also be assigned to atoms in ionic compounds. Of course. The last rule that we're going to discuss here is for number 9, which says that a monatomic ion has an oxidation number equal to the charge of the ion. So Na plus